So this is classified paper 6, topic chemical reactions, page 40, question 6. In this one, the rate of a reaction between magnesium and hydrochloric acid can be followed by measuring the volume of hydrogen produced. So when magnesium is reacting with hydrochloric acid, it gives off hydrogen, and we can measure the volume of a hydrogen. Plan an experiment to investigate the effect of decreasing temperature. Like if we decrease the temperature, how the rate of the chemical reaction will change, like the production of a hydrogen is affected. You are provided with the magnesium ribbon or dilute hydrochloric acid, common lab apparatus. You are advised to draw a label diagram of the apparatus you would use in the space provided. So you have to first, whenever you want to measure the volume of a gas given off, so what you can do, either you can collect over the water, or you can have a conical flask is there.
Gas syringe.
Yeah. And the reaction mixture.
First,
Drop.
we will do it at high temperature and then decrease it and
Right.
compare the volume in unit time.
In unit time. That's right. And there will be a gas, or you can collect over the water as well to measure the volume of a gas which is given off. This is the apparatus, and it should be labeled. Like label diagram is you have to label each part: gas syringe, delivery tube, conical flask, bung, magnesium, hydrochloric acid. So you have to label all these parts. Then, so how we can do this experiment? The points you will mention. So we'll measure the, like, take like 2 grams of magnesium ribbon, add like 10 cm cube of hydrochloric acid of known concentration, mix them and measure the volume of a gas given off in a unit like 3 minutes or 5 minutes, and then repeat the procedure with the different temperature or decrease by decreasing a temperature, and then calculate the rate change in volume divided by time. And then how we can compare the result, we can plot a graph between volume of a gas and time, or we can from that graph we can compare the gradient or the slope. The one which is steeper means higher rate or a faster reaction. So the points, so we can say, like example, take 2 grams of magnesium ribbon, then add 10 cm cube of HCl into conical flask. Then we connect the gas syringe, record the temperature first, then measure the volume of the gas by gas syringe in 3 minutes, and then we'll repeat with different temperature. And then how we can find the rate? We can find the rate either by plotting a graph, like plot a graph between volume and time and find the gradient, that will be rate. Or we can also calculate the rate is equals to change in volume divided by time. Or you can also mention plot graphs.
Or we can say
Yeah,
the more the gas produced in unit time,
yeah, that's
the
okay.
faster the reaction.
That's right. So plot a graph between volume and time and compare this gradient. The one which is having a steeper slope means that is faster rate. So that's how we can work out the rate or the speed of the chemical reaction and how the temperature affects the rate. In question 7, a student investigated the rate of a reaction between a dilute hydrochloric acid and excess of a magnesium carbonate is there. So in here we have a magnesium carbonate attached to a string, and we have a dilute nitric acid. The moment we remove this thread, the magnesium carbonate will mix with nitric acid and a gas, carbon dioxide gas will be given off, and we collect the gas in this inverted 250 cm cube measuring cylinder. So 50 cm cube of a nitric acid was added into a conical flask and the content of the test tube were released, allowing the solid magnesium carbonate to mix with nitric acid. A stop clock or a stopwatch started and the volume of a gas collected in inverting measuring cylinder was measured every 10 seconds for 80 seconds. So after every 10 seconds, we measure the volume and we continue till 80 seconds. Use the inverted measuring cylinder, record the volume of the gas collected. So you can use the screen annotation to complete this. The first one is 0.0. Yeah, that's right. The second one is 27.0 27, 48.0, 1st was 0, then 27, then 48, then 48, 62, 65, 74, 76, 77, and 77. So last volume, the last two volumes are same, shows that the reaction has completed. That's why the volume is same at the end. Now, because the reason why I write these points, as we have to plot a graph here for the next part. Plot the results on the grid and draw the smooth line. So first 0 and 0, so this will be 0 and 0. This will be the first point. So first we have 0 and 0. The next one is 10 and 27. So 10 and 27. So this one is 10 and this one is 28, 27, 10 and 27. Then 20 and 48. So this one is 20. This 50 and below 2 boxes, because each box on y-axis is representing 1 and on x-axis also each box is representing 1. Then 30 and 62. So 30. So this is 60, 61 and 62. Then we have 40 and 65. So this one is 40. And this was 62, 63, 64, 65. And then we have 50 and 74. This one is 70. 1, 2, 3, 4. So 74. And then 60 and 76. So 60 and 76. And then we have 77, 70 and 77, and 80 and 77. So these are the points. Look, whenever we want to draw the smooth line graph, so what we will do, we'll ignore like anomalous result, we'll ignore. As you can see the pattern in the pattern, this point look out of the pattern. So using a freehand, like you will draw a freehand graph, but don't include the anomalous result as it appear not in the sequence. So we'll ignore that and join rest of the points. And when you draw the graph, use thin lines to draw this. Is it clear?
Yes, sir, clear.
The next one of the point anomalous, circle that point. So we have to circle that point which appear to be anomalous. So this point. Next is from your graph, reduce the time taken to collect the 40 cm cube of a gas. So how much time will take to collect 40 cm cube of a gas? So we have to draw a line from here, from 40 cm cube. You have to show this on your graph and then find on y-axis how much gas is collected. What if student use encircle dot points method? They would add. Yeah, that's why it's better you just put a dot instead of dot and circle, or even you use a cross. So according to your graph, you will work out the volume. Say this volume is 11, 12, 13, 14, 15, and 16. So we'll write, according to our graph, we'll write this is 16 cm cube. So when you plot a graph, you will write according, like mention the points according to your graph. Say it is 16 cm cube or 20 cm cube accordingly. So here we will write it as 20 cm cube. Or 16 cm, 16 second, 40 cm cube at 16 second, not because we want to find the time. Then state one possible source of error in this experiment. When we are collecting possible source of error in the experiment and suggest how we can improve this. So how this experiment, like how we can improve this result.
By using gas syringe,
Yeah,
it can be because like the measuring cylinder is filled with water.
yeah, so we can use a gas syringe, or we can also reduce the size of a measuring cylinder. As you can see in the beginning of the question, we use 250 cm cube measuring cylinder. Like here, 250 cm cube measuring cylinder is there. And the gas which we collected was about 77, even it is less than half of it. So because it's easy to, when the values you have a instrument which record a smaller value, it will be easy to read the scale. Like it will have greater sensitivity, reliability in terms of measurement. So instead of using 250 cm cube, we can use 100 cm cube measuring cylinder. Because like, for example, if we collect a 77 cm cube of a gas, so the volume change will be this, like the gas which is collected may stop at this point. But if you use 100 cm cube measuring cylinder, so the difference between the marking will be greater, so you can easily read the values, read the scale. So what we can do, how we can improve this experiment, by using a 100 cm cube source of error, the use of 250 cm cube measuring cylinder. And how it can be improved, there are two ways. Either you can mention improve by using gas syringe, or you can also mention use 100 cm cube maging cylinder. Is it clear, this part?
Yes, sir, clear.
The average rate of a reaction can be calculated using the equation. Calculate the volume of a gas collected between 10 seconds to 30 seconds. So from 10 seconds to 30 seconds, we want to find how much gas is collected. So at 10 seconds,
We can also use the table.
yeah, you can use the table as well, because the values in the tables are actually same as what the points we plot for the result. So directly you can use the table as well. So either you can use your graph or you can use directly the table, because the graph was first, that's why I was using a graph, but you can also use the table here. As at 10 second it was 27, and at 30 second it was 62. So how much difference is there? How much? So 62 minus 27, which
35.
is
40,
62 minus 25,
35.
35. So that will be 35 cm cube. So 35 cm cube of a gas is collected. So we'll write 35.
Over 20.
The first part we'll write 35 because the first they ask only
Yes.
calculate. The next one we'll write divided by. So this is 35 cm cube. But then we have to calculate a rate. To calculate a rate or speed of a chemical reaction, volume of a gas collected, that was 35. And the time taken, 35 cm cube, and the time taken from 10 second to 30 second, that's time interval is 20. So 35 divided by 20. So this will be 1.75. And the unit of, because the volume collected was centimeter cube and the time is second, so the unit will be centimeter cube per second. If it was change in mass, then it will be grams per second. Then sketch on the grid the graph we expect if the experiment was repeated at a lower temperature and label that as L. So if we'll do the same experiment,
Less deep.
yeah, you can use screen annotation, complete, plot a graph for the reaction if it is done at low temperature. This one is done at high temperature. We want to sketch for low temperature. What will the shape of the graph? So it will be less steeper. Yeah. But the final product should not change. Why the final should not change? Because we did not change the concentration of the limiting reagent. And you have to label that as L. So you will label that as L. Another question, magnesium react with dilute sulfuric acid at room temperature to form hydrogen. Plan an experiment to find the rate of a reaction between magnesium ribbon and hydrochloric acid. Part F. Student calculate the total volume of a gas collected in this reaction would be 85. Suggest and explain why the actual volume of gas collected was different.
Some gas dissolved in the water.
Yeah, part F, some gas, because what might happen when you're collecting a gas, um, when you're collecting a gas over the water, so the one possibility is there that the gas might dissolve in water. If the gas dissolve in water, then as a result, you will collect a lower volume of a gas. This is the case or happen when we are collecting a gas over water. Some gases are readily soluble, some are partially soluble, and some are insoluble. So if it's a completely insoluble gas, it won't dissolve. But carbon dioxide partially soluble, so that's why the actual volume won't be 85, it will be less than 85. Magnesium react with dilute sulfuric acid at room temperature to form hydrogen. Plan an experiment to measure a rate of reaction. It's the same experiment, how you use the result like we did in question 7, question 6, sorry, not even question 7 is also the same way. We can, like hydrogen gas is given off, so we can have a magnesium ribbon and hydrochloric acid. So here we'll have a magnesium. When we add a gas given off, we collect the volume of a gas, but we have to include time as well as we are measuring a rate or the speed of a reaction. So it is same as question number 6 we discussed. The points quickly, I will mention the points what we will do. Like we'll add a known mass of a magnesium to sulfuric acid and connect a gas syringe, measure the volume of a gas at a specific time interval and record the time or record the volume of a gas in a specific time interval. You can mention 3 minutes or 5 minutes. And then to calculate the rate, it's a change in volume divided by time. Or you can also allow the gas to escape. Whenever a gas is given off, you can allow the gas to escape and measure the change in mass over time to calculate the rate or the speed of that chemical reaction. Both ways are acceptable. Question 9, investigating the rate of a chemical reaction when sodium thiosulfate is mixed with hydrochloric acid, a precipitate sulfur will form. So as a result, when the sulfur will form, we'll start the timer. The moment we mix them together, we start the timer. And as a sulfur form, the light cannot pass through. So this cross, the observer, we looking from the top, that this text or printed words are there or a text, that will disappear because the light cannot pass through as a solid is formed. So in experiment 1, a large measuring cylinder was used to pour 50 cm cube of sodium thiosulfate into 250 cm cube conical flask. Then the conical flask was placed on a printed sheet of paper and 10 cm cube hydrochloric acid was added. A timer was started immediately and the mixture was swirled. The time taken for a printed word to disappear was viewed. Then in experiment 2, we use a large measuring cylinder and poured 40 cm cube of thiosulfate, 10 cm cube of water, and 10 cm cube of hydrochloric acid. In experiment 2, we took 35 cm cube of sodium thiosulfate, 15 cm cube. Hydrochloric acid is same. The only thing what we did, because the total volume of the solution was, we took 50 cm cube thiosulfate and we took 10 cm cube of hydrochloric acid. So the total volume was 60. That's why for each experiment, the total volume should be 60 so that the volume and concentration are directly proportional. Like the substance which is having a higher volume in the mixture will have high concentration. So here 40 cm cube of thiosulfate, 10 cm cube of water, 10 cm cube hydrochloric acid makes 60. If 35 cm cube of sodium thiosulfate, 15 cm cube of water, so how much hydrochloric acid is there? 10, because we want to make it 60. Same way, 30 cm cube of thiosulfate, 20 cm cube of distilled water and 10 cm cube of hydrochloric acid. Here 10 cm cube of thiosulfate, 40 cm cube of water, again 10 cm cube of hydrochloric acid. So amount of hydrochloric acid we did not change. Only thing what we did, we use different amount of water as we change the amount of thiosulfate. So the record of the volume, just a minute, I will just a minute. So these are the points you have to record. The experiment 1, 2, 3 and 4 and 5 are done. You have to volume of the water which is added and the time for the printed words to disappear. So you using this stop clock diagram, you have to tell it is in seconds. So this is 0 and this one is, it's not in a, each box is, it's not in 22 point. It cannot be 22 point because each is representing 1. So this one, like each is representing 1. This is like 10 seconds, 15 seconds, 20 seconds, 25, 26, 27. So this is 27 seconds. This one was correct. You read 33. This one was 45. This one, because the center one is a minutes. So 1 minute and how many 6 seconds? So 1 minute means 60. Like, because this one is representing the minute and the outside one is representing a second. So 1 minute means 60 seconds and then 6 seconds. So 60 plus 6, 66. And for this one, it's 1, 2, and 3 minutes. And the last one is 21. So 180 plus 21, so it will be 201. So this will be 201. And what about the volume of the distilled water we use? We use 0, like in the beginning, we did not use 0, 10, 15, 20, and 40. So it was 0, 10, 15, 20, and 40. So these are the values for experiment. The first experiment was 27, 33, 45, 66, and 201. So you can see clearly that as we reduce the amount of thiosulfate, as the concentration of thiosulfate in the mixture is decreasing, the rate of a reaction is also decreasing. So it is taking longer time for this cross to disappear or for the printed text to disappear. The next part, we have to sketch a graph. Usually for chemistry, you don't have to label the axis. Already they label the axis. So plot the results for experiment 1 to experiment 5 and draw a smooth line. So at the volume of thiosulfate, use 50, 40, 35, because we want to sketch a graph for volume of the thiosulfate use. So it was 50, 40, 35, 30, and 10. The first, at 50 it is 27. So at 50 it is 27. Here from like there are 10 boxes which are representing 30. So it means each box is representing 3. So 27 will be, this is 30, this will be 27. So 50 and 27. Then we have 40 and 33. So this one is 40 and 33, like one box above 30, 33. Then 35 and 45. So 35, so this was 33, 36, 9, 42, 45. Then 30 and 66, so 30 and 66. And then we have 10 and the volume is 10 and 201. So 10 and 201. This will be 207, 204, about 201 somewhat here. So these are the points. From your graph, then we have to draw the smooth line graph. So we have to join these points. The next part, from your graph, reduce the time for the printed word to disappear from viewing if experiment 2 was repeated using 20 cm cube of thiosulfate. And so how we can work out if we use 20 cm cube of thiosulfate? So we'll draw a line. So we'll draw a line from 20 cm cube of thiosulfate and find the time. On y-axis, each box is representing 3. So this one is 93, 96, 900, 96, 93, 6, 9, 102, 105, 108. So this will be 108. So this is equals to 108 seconds. Is it clear, this one?
Yes, sir, clear.
The next is the rate of a reaction can be calculated using an equation as shown. Calculate the rate of a reaction using your answer for C1. So our answer for C1, it was 108. So if you want to calculate the rate, it's 1 over C1, so 1 over divided by 108. What's the answer? 1 divided by 108. 1 divided by 108.
Equals Mr. 0.00925.
So 0.00925 second inverse. In which experiment 1, 2, 3, 4, or 5 was the rate greatest? Which experiment the reaction was fast?
The time in which the time taken was least.
Yeah, so which one the least time was taken for experiment 1? So we'll say experiment 1, because in experiment 1, the reaction completed, I guess it was 27 seconds. So experiment 1 was the fastest. Then explain in terms of particle why the rate of a reaction was greatest in experiment 1.
There were more sodium thiosulfate particles per unit area, so they collided more effective collisions, resulting in higher rate of reaction.
So more particles, more or high concentration of sodium thiosulfate, like more particles of sodium thiosulfate. That's why more collagen, higher concentration, faster rate was there. Give name of more accurate piece of apparatus measuring the volume than other than measuring cylinder. So here we use a large measuring cylinder port 50 cm cube. So what else we can use? Burette. Why we did not mention pipette specifically? Because if we use pipette is for 25 cm cube. That's why we did not mention. Suggest the effect on the result using a 100 cm cube conical flask as compared to 250 cm cube conical flask. Look, if we use 100 cm cube conical flask,
More accurate.
no, it's on the result you
No
have to
change
test.
on the result.
Look, how the 100 cm cube conical flask will be differ from 250 cm cube conical flask. In this case, we took 50 cm cube. Like in the begin, like the total volume of the mixture, sodium thiosulfate, hydrochloric acid, and water, it was all the total volume was 60 cm cube. So as a result, when we are using a 100 cm cube conical flask, so that 60 cm cube, like it will have a large, like greater depth will be there of a solution. But when the same 60 cm cube is added to 250 cm cube conical flask, it will have a smaller depth. So as this is having a larger depth, so when the solid will form, as a result, when the solid will form, the text will disappear quickly. Because like if a solution is having a greater depth, then as a solid is formed, so you won't be able to see the text which is under this. Here, because the depth is shorter depth is there, so still you are able to see for a longer period of a time. So in a 100 cm cube conical flask, this text will disappear in a short time. Where in 250 cm cube conical flask, it will take longer time for the cross to or the text to disappear. The reason is that because 100 cm cube, it will have a greater depth of solution, so it will be difficult to see through. Is it clear, this one? How it affects the result? Then sketch on the grid the graph you expect if all the experiment were repeated at a lower temperature. Say if we draw, it will be the curve will be same.
Less steep.
Yeah, and the time it will take a longer time. Like example, this is our original curve.
It would
So
go down more.
so do down or because we did it will be
Down,
above
up,
because in the
more above.
question, yeah, we repeated at a lower temperature. So the same same sketch will be there, same type of result, but it will be like, for example, for 10 cm cube, say it was taking 201 seconds to disappear, but now at a lower temperature, it will take longer time. So the whole graph, symmetrical graph will be there, but above. If we repeat the same experiment at lower temperature, it will take longer time for the text to disappear. That's why it will be above the original one. So same shape will be there, but it should be above.